Hello, welcome back to Cracking the Cryptic, and pretty sure this is a debut puzzle for B Frange 17. And I see lots of arrows and lots of cages in the grid. I'm hoping this is approachable. I don't know though. We'll only find out in due course. You can look at the video length already, I guess. Now, you cannot tell yet how hard the puzzles are going to be in our Patreon reward on the 1st. It's going to be the Hollywood lunchbox, and it's coming at you. Do check out join us on Patreon. Check out the Sudoku reward on the 1st of the month. It's going to be 7 puzzles of sandwich style, and you can enter the competition until the 20th. I think you're going to have great fun with it, but do check it out. You can also spend your time identifying the film and TV sandwiches shown. And that's coming out on the 1st. So there's also other content on Patreon, connections, videos, crosswords, and all sorts of other Sudoku content, packs and long videos and things every now and then. Do check it all out. And don't forget our apps. We have both Killer Sudoku and Arrow Sudoku amongst the apps we have. Oh, talking of Sudoku, B Frange 17, who wrote to us with this puzzle, I'll do that in a second, but all the apps are available on the links under the video, along with Sven's SUDOKU PAD and our merchandise. Yes. Now, this very much surprised me. B Frange 17 wrote to us, and throughout their email, and the rules of the puzzle as they had them written, and the title, I think, at the time, Sudoku was spelt wrongly. Now, I mean, I'm not mocking. Lots and lots of people in the world spell it S-O-D-O-K-U, and there are other variants too. But it is quite unusual for somebody to have watched our channel for a while and write to us with the wrong spelling, and I was surprised. That's all I'm saying. I'm not mocking. Loads of people have dyslexia. Loads of people haven't noticed what the spelling of Sudoku is, or indeed have been taught it by other people in the wrong. So it's easily done. But I was just a bit surprised. So it says nothing about the quality of the puzzle. It's just something I noticed because I am absolutely a card-carrying pedant, and I spot these things, I'm afraid. Anyway, so this... Nonetheless, the puzzle is called 22. I don't know if it particularly commemorates an age or anything for B Frange, but there are a number of 22 cages in the puzzle as well. So I'll go through the rules, which are very straightforward. Normal Sudoku rules apply. 1 to 9 goes in every row, every column, and every 3x3 box. Digits along an arrow sum to the number in the circle, so those 3 digits will add up to that. There's obviously 2 separate arrows coming from this circle. Digits in a cage cannot repeat and sum to the given total. And the given total is always 22 in the cages in this puzzle. So give it a try. I'm going to start now. Let's get cracking. Okay, I'm going to start with the 22 cages because I know that a 3-cell 22 cage, and 4 of these cages are 3 cells, must have a certain digit in, and that digit is 9. You can only make it up in 2 ways, 985 or 976, and both of those have a 9 in. So that means that in this 22 cage there is a 9, but there is also a 9 in this 22 cage, and since we're not allowed to repeat a 9 in box 5, I can write the 9 into that one, and there's our first digit. This cage needs a 9 in as well, and we now know it's not in column 6 or column 5. So we're away. This cage needs a 9 in as well. Now we have a little 2x2 area with 2 9s in. And that means the 9 in row 4 is going to be in one of those cells. Now, we can never put a 9 on an arrow that has a length of more than 1. But we can put it in a circle. So maybe we can't go any further with that. Nonetheless, we know that this is a 5, 6, 7, 8, 9 quintuple in box 5, because those are the digits that are needed in these cages. These other ones in the box are 1, 2, 3, and 4. And in fact, all of these 3-cell cages only have those digits in. And I'm thinking about colouring them by flavour, but it may not be necessary. Let's look at some of the rows and columns which have 5 arrow cells in, because that's quite a large number. And I'll tell you why. So let's start in column 9. These 5 arrow cells add up to at least 15. I know that because the minimum 5 digits are 1, 2, 3, 4, 5. They add up to 15. And that means that's the same total as for these 2 circles. And they therefore have to be selected from 6, 7, 8, or 9. And they add up to exactly 15. Now the same is true in row 2 and in column 2 with those circles. And well, okay, the same is true in row 9, but I'm not using that circle because it's this circle that has the arrow. So, are they some sort of circular pattern that I can actually use? I'm not sure. That is on a 3-cell arrow on its own, and therefore must also be 6, 7, 8, or 9, because the minimum for 3 cells, which are 1, 2, and 3, add up to 6. I don't really know where to go next. I'm just wondering if in column 9, if that was 1, 2, 3, 4, 5, these 2 would add up to 15, and these 2 would add up to 15. Maybe the other thing to do is to go, what if they were 1, 2, 3, 4, 6, which is the only way they could add up to 16. Then these would be 9 and 7, and this would be 8, and that would be 5. I don't quite know. Oh, there is a 9 in one of those cells. The only place, there's no 9 therefore here. The only place for 9 in box 9 is one of those 2. Ah, and that's quite interesting. If this was a 9, these 2... Oh, I was going to say they could only add up to 15, but they could both be 8s. I don't quite know what's going on here. Okay, the idea I had earlier was to colour these 22 cages according to the flavour of... it's basically the flavour of the digits that add up to 13 in the cage. So in this cage, let's call, it's either an 8-5 pair or a 6-7 pair. We'll call it purple. This cage, they have to be the other flavour because that cell can't be purple. So we'll call that green. And either purple is 8-5 and green is 6-7 or vice versa. Now this cell has to be purple and one of these is purple. And 2 of these are green. And it's not uninteresting. Actually, this is, for some reason, it's taken me that long to notice that this is a 5, 6, 7, 8 quad, and everything else in column 5 is 1, 2, 3, or 4. And that one is not on this arrow, these arrows. Right, now that is interesting. So, if these added up to 15, they would be 1, 2, 3, 4, 5, and that cell couldn't be filled in. If they added up to 16, they would be 1, 2, 3, 4, 6, and that cell couldn't be filled in. Therefore, now, in this row, we have to say at least 17, because they could add up to 18. I was just wondering if I'd got these wrong on the basis that I thought they could only be a minimum of 15. No, I haven't. It's okay. Anyway, these add up to 17 or 18. Therefore, there is a 9 in one of these cells. They're either 9.8 or 9.9. And therefore, this is not a 9 because it sees them both. And whichever one or both is or are a 9, it's not here. So that now is the only place for 9 in box 9. Now this can't be a 9. This, actually, I could have done this earlier. This has got to have a 1 on it because it adds up to 6, 7 or 8, and you can't do that with digits higher than 1. The same is true up here. So there's a 1 there and not there. Now, these cells add up to 17 or 18. Now, either way round, they've got to have a 1 and a 2 in. They might avoid having a 3 in. Well, they do avoid having a 3 or a 4 in. So if that's 3, these are 1, 2, 4, 5, 6. And then we would have 7 and 8 in those two cells. If that's 4, these are 1, 2, 3, 5, and then either 6 or 7. Now, I'm wondering if this makes it impossible for this to be an 8. If that was an 8, this couldn't be 1, 3, 4, or that would be broken. So this would be 1, 2, 5. That would be 3, 6. That would be 4. That would be 7. That would be 8. It does look possible. It was difficult for a moment for this to be 8. Anyway, now the other thing is, what's going on here? If that's a 6, this is 1, 2, 3, 4, 5, and then we've got a 7, 8 pair here. That would have to be 9. If this is a 7, this is 1, 2, 4, this is 3, 6, that's 8, and that's 5. That's not as good. If that's 8, I think there are choices down here. So, okay, I didn't go quite as far as I was hoping. Oh, where's 9 in this box? It's confined to those cells. It's got to be there. Oh, that's just straightforward now. Now that's not a 9. Therefore, there is a 1 on this arrow now. I'm aware that I'm corner marking across boxes, which is a bit of a danger, but it seems important. Now, if these only added up to 15, if these were 1, 2, 3, 4, 5, that would have to be an 8, 7 pair, and we'd know the order. That would be 6. And that's impossible. Right. If these only added up to 15, which is the only way of keeping 9 out of there, they would be 1, 2, 3, 4, 5. This pair would have to be, I was going to say it would have to be 7, 8, because I was trying to keep a 9 out of here. Right, if 9 is not in here, those can only add up to 15. Those will be 1, 2, 3, 4, 5. This would be 6 or 7, but on a 3-cell arrow with an 8 in the circle, that's impossible. So this is a 9. Now, what next? Where's 9 in this box? It's in one of those two cells. Oh, and that's sort of an X-wing left with 9 there, and I've got 2 X-wings on 9s left, and I can't really deal with them. Okay, right, this still can't add up to 15, because that would be 1, 2, 3, 4, 5, that would be 6, and this would be 7 or 8, which can't go in a 9 thing. So this, how about 16? If that's a 7, this is 1, 2, 3, 4, 6, that would be a 5. This would be 5, 3, 1. That would be a 4. That would be 2, 7. And that works. So we got that down to 7 or 8, but we couldn't seem to get it down any further in terms of possibilities. If it was 7, this would be 1, 2, 4. That would be 3, 6. This would be 5. That would be 8. So if this was 7, that would be 8. So one of those two is 8. Oh, and these digits, is that interesting? They all have to be in the sums of their two circles, which add up to at least 15. No, maybe it doesn't help to consider those. Obviously, this 22 cage doesn't have a 9 in. 8765 are the maximum, that's 26, that's 4 degrees of freedom, one of which goes because of this. This is tricky to make headway in. I don't really know what to do at the moment. If this pair wasn't 4, 5, then it would use either a 2 or a 3. And it would use either a 7 or an 8. And that would form a quadruple, either of 2, 7, 6, 8 or of 3, 6, 7, 8. If it was 2, 6, 7, 8, that would have to be 1, 3, 4. If it was 3, 6, 7, 8, that would have to be, well, that could be 1, 2, 4 or 1, 2, 5 then. No, that's not quite the way to go about it. 1 in the central column has been reduced to 2 possible places. I can't see that either of them are particularly difficult to fulfill, but I don't know what's going on. Right, if that is a 7, these add up to 32, and these add up to 13, and there are 8 and 5. Also, if that's a 7, it's the same deal in this row. These add up to 13 and are 8 and 5. So all of these cells would be 8 and 5. And we would know that was 5, so that was 8, so that was 5, so that was 8. And if that was 8, yeah, interestingly, this would have to be 7. I know that those two add up to an odd number, because those must add up to an even number, given the circle and its arrow, and those. And the column adds up to an odd number, because 1 to 9 adds up to an odd number. So that would be a 7. So if this is a 7, that would be a 7 as well. Oh, and this would be a 6, which is quite powerful. That would have 1, 2, 3 here, and 4, 5 here. We'd have had 5, 3, 1, and 4 there. That would be 2, 7. Oh, it all works. Just about. Let me think about this again. So if that was a 7, this is 8, and that's 5. This is 5, and that's 8. And with a 7 here, and a 5 gone, this is either 1, 6 or 3, 4. That's not actually all that helpful. Okay, so if this was a 7, that would be 1, 2, 4. This would be 3, 6. 5, 3, 1, 4, 2, 7. It feels like there's something going on there. Oh, well, this I hadn't even understood. These 3 cells add up to some total that I haven't thought about. Because in this row, we know that that's 9, and that's 9. So those are 27. So these 3 yellow cells add up to 18. If that is a 3, these have to be 8 and 7. If that's a 4, they have to be 8 and 6. This is the remaining, no, this is purple, not the remaining, but a digit in this column can't be green. So that is a purple digit of 6, 7, or 8. Now, this, interestingly, I can colour this as well. I don't know if this is going to help at all, but I can colour this. It can't be purple as well, because 2 purples together add up to 13. That would make this a 6, 7 pair, and this wouldn't get the total of yellows to 18 at all. So that's green. I don't know how that helps anybody. It means there is 1 green digit here. There is 1 purple. No, I'm not sure. I was going to say there's 1 purple digit there. I don't know that. Something in this bottom row. Come on, what's going on in the bottom row? If this it was 1, 3, 5, which actually I think is quite likely, that's a 4. This is 2, 7, and that's a 6, 8 pair. If this is 1, 2, 6, that's a 7, 8 pair. This is 4, 5, and that's 3. If this is, what's the other one? 2, 3, 4. That's impossible because of that. So there is a 1 here. It's either 1, 2, 6 or 1, 3, 5. And this digit can't be a 1 in this column. Thanks, pencil marking. I also don't think it can be a 2 or a 3, because don't they have to be in this total of, this is a total of 16 or 17. Even 17, I think, needs a 3. Yeah, 1, 2, 4, 5, 6 adds up to 18. So 1, 2, and 3 are in that group of cells. And this is now 4, 5, or 6. It can't be 4, in fact, because that would make this 4, 1, 4. So that is 5 or 6, which has got a colour, purple or green, but I don't know which. And then this is either 1, 2 or 1, 3 to make up this sum. So 5, 3, 1 would be 4, and that would be 2, 7. 6, 2, 1 would make this 4, 5. So this is 2, 7 or 4, 5 over here. This is complex suddenly. Again, I might be just missing something. Oh, this digit can't be 9. Oh no, there is, sorry, I was going to say it couldn't be 5, 6, 7 or 8, but that's not true. It could be the other purple digit, which can't be 8 because the purples add up to 13. Nah, that's not very helpful. All I'm ruling out of there now is 9 and 8. That's not interesting enough to proceed with. Oh, come on. If that was a 5, this would be 5, 1, 3, 2, 7. That would be 6, 8. One of these two is an 8. That means either one of these two cells is an 8, or, well, we already know one of those two is an 8. It doesn't get anything done. Curses. Okay, I don't know what, this is harder than I thought it was going to be. That's definite, and it's quite amusing. I don't know what I'm meant to be looking for in the puzzle now. There's so many arrows going around in the circles that seem to be trying to help me out, and I can't see what to do. Can I use the fact that this is either 2, 7 or 4, 5? I don't think so, realistically. So, 9, 5, 6, 7, 8. We've still got one. Look, there's a 1, 2, 3, 4 quad. Hadn't seen that coming. Everything else in the column, oh, it's 5, 6, 7, or 8, including this baby, which is not 8. This is now a maximum of 3. And what does that mean? There are 2 low digits on this 9 arrow. And by low, I mean 1, 2, or 3. Every 3 cell sum adding to 9 uses 2 of the very low digits from 1, 2, and 3. So 2 of them are there, and 1 of them is now here. And therefore, these other cells in the row are at least 4. I think we worked out that couldn't be 8. I actually think we might have worked out more. 16, in fact, oh, what's happening here now? I don't know. If that was a 7, these add up to 32. These had to be 8 and 5. If that's an 8, then these add up to 34, and these add up to 11 then. And then there's a lot more freedom. So if that's 8, the trouble is that's barely narrowed down then. Okay, but that's 9, that's 4, 5, 6, or 7. What does that mean? This is at least, or no, at most 5? Yeah, I don't think that's quite. These 1, 2, 3s, it's really interesting. There must be a 4 in one of those cells, so that's not a 4. So this has got a bit more pressured. Now, how many high digits from 5, 6, 7, 8 does this need? If you had 2 low ones, 3 and 4, you'd need another 8 and 7. Remember, this can't have any 9s in it. So the 8 and 7 couldn't both be in that column because this will need either 8 or 7. Now, this is either these are all high digits, in which case those 2 are green and that one's purple. And by high digits, I'm meaning 5, 6, 7, 8. Or that's a 3 and these are 4, 8, 7. So none of these are 1, 2, or 3. Is that worth knowing? I think this can't be 1, 2, or 3. It doesn't quite make that a quad. Ah, this is getting so tricky now. Here's another thought. If that's an 8, I don't think this can be 1, 2, 5, because that would be 6. And then you couldn't make up the 9 sum, because 1, 2, 5, and 6 takes 1 digit from each of the things that can make up 9. So there can never be a 5 on this arrow. And if it's an 8, this is 1, 3, 4. And if it's a 7, it's 1, 2, 4. So there's always a 4, and we're only selecting from 1, 2, 3, and 4 there, which is again contributing towards 1, 2, 3, 4 quads. The 4th of 1, 2, 3, 4 must be on this arrow in this column, and therefore this is not a low digit, which is unsurprising, but I hadn't done that before. Could that even be a 5? This would be a 6. Oh yeah, these have to add up to an odd total because those will add up to an even total in the column. So 5 and 6 there would be 11. That would actually be the right number for this to be an 8. These two either add up to 11 and that's an 8, and they must be 5 and 6 then, or to 13 with that being a 7, in which case they're 5 and 8. So there's always a 5 in those cells. They're either 5, 6 or 5, 8. That can't be a 7. These two are either 5, 6 or 5, 8. I'm wondering if that's true here as well, because this row has similar properties to column 2. If that's a 7, these add up to 32, and these add up to 13, including an 8, and they're 5, 8. If that's an 8, these add up to 34, and these add up to 11, not including an 8. But now I can't see in this case, oh, they could be 7, 4. So it is a bit different, annoyingly, from column 2's case. Now, 1 and 4 are definitely in use here. So this is either 2, 7 or 3, 6 on this arrow. Oh my goodness. It's so pressured on both the high and the low digits, but I cannot see the way to resolve it. So this has at least 2 very low digits. If that's 1, 2, 3, that's 4, 5. And this is 6. If that's 1, 2, 4, this is 3, 6. And that's 5 amongst 7 and 8. If that is 1, 2, 5, that's 3, 6. That's 7, that's 4. And if that's 1, 3, 4, that's 2, 7. And that's 6, and that's 5. Okay, so I think the various possibilities only allow this to be 4 or 5. Let me check that again. 1, 2, 3, 6, 4, 5, 9. Oh no. That allows this to be 8 or 7, so I can't rule anything out of there. Botheration! Oh, I was sure this was going to break down a bit more easily once I got going. It's a very clever puzzle. I've got to say that now. This cell is coloured, isn't it? Because it's 5, 6, 7 or 8. I could have done that ages ago. In fact, I thought of doing it and forgot. So that is purple. It's the counterpart of that in making 13. So it's not an 8. Now 8 in the column has to be in one of those 2 cells. What does that mean? And does it tell me anything about this? This could still be purple if that was a 6, 7 pair. That's the only way. Now, if I could say that one of these was definitely 8, that would be an X-wing, and that would be very helpful. So how could one of these not be 8? If that was a 6, 7 pair, what does that mean? For that to be a 6, yeah, this could be 7 and that could be 8. Now, okay, that would be a 7 and this would be 1, 2, 4 and that would be 3. In fact, this is going to use, no, it's not necessarily going to use the other 3 digits from 1, 2, 3, 4 that aren't in use here. Not necessarily. Maybe focus on this one. If this was 6, 2, 1, that would be 8, 3, 5. Okay, that works. If this was 2, 3, 4, that would be a 1. And if this was 1, 3, 5, that would be a 2. I can't see how that's resolving anything. I've got to find another set somewhere. Like, for that not to be a 1, 2, 3, 4 quad, this would have to be a 5. 5, 2, 1 there. 3, 6 here. 8, 4, 7. I can't see the problem with that. This is so irritating. That's purple. There is a purple in one of these three cells, and it's 5, 6, 7, or 8. It could even be there though. That's not good. Not good for me. There's a purple to go in this row as well, somewhere. I don't think the colouring of purple and green really did anything for me, unless I'm totally missing what it did. One of those is purple or green. If that was 7, 2, that's a 5. No, I don't know. I mean, I can really see how this puzzle is pressuring, and any move anywhere is pressuring everywhere else. But I can't get it to actually tell me what it's achieving. Okay, let's go back to this 22 cage. The puzzle is called 22 after all. So what we said before was the only way for this to have 2 of the 1, 2, 3, 4 digits is if it was 3, 4, 7, 8. And it couldn't have 7, 8 there, so one of those would be 4. Could it have 7, 8 here? If that was 7, 8, that would be 6, that would be 5. It doesn't really matter, because if I find it can't be 7, 8 there, and I think that would be complicated, it could be 7, 8 there, so not an interesting conclusion to attempt to reach, I think. Should I be doing something with 1s even? We had a 1 in those cells. There must therefore, no, don't know. I was going to say there must be a 1 in one of those two. I don't think that conclusion is valid. Okay, if that's a 1, one of those is a 1. Maybe I can just find a falsification. Also, one of those would be a 1, that would be a 1. I don't know. I don't think this can be 1, 2, or 3, because we can only have 2 low digits and there'd be 3 or 4. Well, that's slightly interesting. We're working on a quad, or on a quint there, maybe. If those are 1, 2, 3, I don't know. It's not interesting enough. Maybe keeping 9 out of that is ridiculous. That would make these 2 9s. If that wasn't a 9, it can't be an 8. It would have to be 7 at most, and that would be 3 at most. No, I can't see what that's doing. Wow, I'm really getting bogged down here. 2 greens and a purple in row 7. I mean, that's clearly from 1, 2, 3, 4. I just hadn't marked that because I've got the 5, 6, 7, 8 quad here. I don't see how that's going to help, but you know, you never know with these puzzles. You sometimes get somewhere and some very innocuous pencil marking actually reveals what's going on totally. I mean, I've seen that this is somewhere between 3 and 7. I've seen that for ages and I haven't marked it, and I don't see how it helps me to progress. I've got to come back to this 22 cage, surely. Does it have to have a purple digit in it? Because that's quite interesting. If it didn't have a purple digit, yeah, that's interesting. So if it didn't have a purple digit, the only 2 high digits it could have would be in these cells, because this can't be green. So if it didn't have a purple digit, it would have 2 green high digits. The whole point is the same 2. If it only has 2 high digits, they can't be the same color, because they would be 8 and 7, and one of those is purple and one of them is green. So I think this is now purple, because it can't just have 2 greens. Therefore it must have a purple, and it's got to be there. Well, it's definitely purple, 5, 6, 7 or 8, and it's the complement of this one. It's the same as this one. So it's not 8, it's 5, 6 or 7. Now we've got a 5, 6, 7, 8 quad in this box, and those are from 1, 2, 3, 4. Now, those add up to 10, plus these are the sum of those. What does that mean? It doesn't mean anything. I don't know. So here's another thought though. If 4 is in this group of cells, it's in this group of cells, and they must be 4, 3, 2, and that must be 1. For 4 to be on a 9 arrow, it must be with 2, 3, 4. And that would also be a 2, 3, 4 group, and that would be 1. So 1s would start appearing in these places. It's pretty prescriptive. Oh, this is not possible. Right, because of column 5. So what I was saying was, if this arrow is 2, 3, 4, that's the 1 in the row. That's the 1 in box 1, in box 2. And because of where that forces 1s around the grid, the 1 in box 8 is there, and there's nowhere for a 1 in box 5. So that is not a 2, 3, 4 arrow. There is no 4 in those cells. There is definitely a 4 in those cells now. This is either 1, 2, 6 or 1, 3, 5. This is now 5 or 6. That is a coloured cell and is green, because the 2 purples are here. And now we cannot have 2 coloured cells, green and purple, here, because we've only got 1 left to go in this column. Therefore 4 is in this cage, and it must be 3, 4, 7, 8, and that is actual progress, because now I can write 3, 7 and a 4, 8 pair into this. What's more, I know that 7 and 6 are the purple digits. I was going to call them the purple bricks there, but that would be quite false advertising. And that 5 and 8 are the green digits. This is green. Does that have to be 8? 5 and 8. How do I know that's green? How do I know that that was green? There was some reason. Oh, it's because these had to add up to 18, I think. Yes. Okay, I'm going to trust that pencil marking, and that is now an 8. And these add up to 10, but there's 2-way rounds for that to occur at the moment. But we got an 8 there. And now there's an 8 in one of these 2 cells. Well, there's definitely an 8 in one of those 3, because none of these can be 8. So that's not 8, that's 4. That's 8 and is green. Okay, well, we've got some progress here, and now I've just got to find a way to use it. I reckoned earlier, this is now 6, that once there was so much pressure being applied around the grid that once something started happening, it would happen throughout, and that is bearing fruit a bit. Look at this. This is all working along the bottom now. That's a 2, 7 pair. So this bottom row, largely done. That's the only place for 4 in the column. That means this isn't a 6. This is either 1, 2 or 1, 3 up here. That's not a 4 as well. Now, come on, keep going. This needs a 1 in it, and that's not a 1 therefore, so this isn't a 7 anymore. And in fact, it wasn't a 7 since we put 7 in the box in the same column. And those don't have a 3 in. That's a 1, 2, 4 triple, so that's the 3. Oops, that's 1. That's not a 3. That's 1 or 2. Yeah, things are happening by Sudoku now, which is exactly where I want to get to. That can't be 1, 7 or 3, 5 in its box. So it's 2, 6. And that's now not 6. 3, 4 and 7 still to place in box 7. If that's 3 or 7, this is 6 or 2. And we've got a 5 there. So with no 5 there, can that still be a 7? 7, 1, 2, 4. Yes, bother. Yes, it can. I thought that was going to unwind. This now is either 3, 5 or 6. We're going well. We're going well. We still need a bit more. That's not a 7. So, if it's a 6, that's 1, 2, 3, that's 4, 5, and that's a 7, 8 pair. If it's an 8, that's a 7. So one of these is a 7. Oh, look, there's a 2, 7 pair here looking at that cell. That's really quite straightforward. That 6 now looks at that. That finishes its arrow. This becomes a 6. That must be 2. And now we've got 8 in the circle. 6 there. Now it's coming, I think. 8 there means this is 1, 3, 4. And that's 7, 2. That's not a 7. Let's get rid of the corner marks. Right. This is 4 or 7. So is this. 4 or 7. 5, 9, 4. 4. We've had 4 in the box. There we go. That's a 4. This is now a 1, 3 pair. That must be right. This is where 2 goes in the box, not actually on an arrow at all. 8, 1, 3, 4. That's become a 2. That fixes 1, 2 down here. That's become a 5. These are 1, 3. Oh, that has to be a 5 because it sees a 3, 4 pair. That's 1 or 3. This is now 7 with 3 on the arrow, 1 there. And it is all coming. That one deduction was indeed all we needed. Oh, look, 9 ended up not being in the circle. I was sure it was going to be, and it was going to be a case of having to prove how. That's a 6 now, which is clearly a 2, 4 pair. That's a 1. This pair must be a known pair. 8, in fact, we can put in the 8, and that's a 7. That sorts out 6 and 7. Can't believe these aren't resolved yet, but I can't see how yet. 2, 6 there. 2, 7, these are done. In this column, that's a 3, that's a 1, that's a 3. Okay. This is obviously 1, 2, 3 now. That's quite a big deal. This is now a 4, 5 pair. This is 8 and 1. 4, 5, 6 up here. The top one can't be 6. Okay, 4, 3 there are done. 4, 5 here. Now, that's 5, 1. That goes across to 2, 1, and 2, 4, and 3, 4. And a 5 there. Yes, I can finish off these. Now we come back down to these green and yellow cells that started the whole logic chain. And they must be doable. 8 can be written. No, that's not 8. Oh, 7 has sorted out 9 and 7. This is 5. That makes this 8, 9, 8, 5. What a lovely puzzle. That's really, really, really good, B fringe 17. It's intriguingly difficult. I'm sure it's not as difficult as 46 minutes suggests, but I needed every step I found to get through that, and none of the middle ones were easy. So you get a decent start, then you get stuck, but there's these little pebbles falling the whole time until it eventually becomes an avalanche. Brilliant puzzle. Thank you for watching, as always, on the channel. Hope to see you again soon. Bye for now.